To get started, we're going to welcome Neil Desai from Elastic. And Neil is going to talk about Kubernetes. And yes, there's been a lot of talks recently about Kubernetes, about attacking Kubernetes, about defending Kubernetes. But there hasn't been that much talk about one of the key aspects of DecSecOps, which is continuous monitoring. So how can we monitor our Kubernetes infrastructure? Well, welcome, Neil. Look forward to enjoying your talk. And as we've done with the other participants, we will maybe have a chat after this.
All right, great. Thank you very much, sir. I appreciate that. Everyone, thank you very much for taking time out of your day to come and listen to me talk here. And as we said, we're going to be on for the Q&A afterwards. So we'd love to be able to chat with you as far as what we're doing here and what you could do around monitoring your Kubernetes infrastructure. So again, my name is Neil Desai. I'm a principal security strategist here at Elastic. And as many of you know, right, Elastic, you've probably seen us around everywhere. I know SANS gives a lot of talks where we're used in there. And so a lot of what we're going to be able to do today, you can do in your own environment. We do have a cloud trial. You could try it as well. Plus, we have our basic version, which is free and open to the community that you can play with and kind of test out. So when I started looking at this, one of the things I wanted to understand is exactly what does Kubernetes mean to different people? Because a lot of the talks that I've seen out there talking about Kubernetes infrastructures that are maybe self-hosted. And as we see a lot more people going out to the cloud environments, they're starting to have to think about using Kubernetes in Amazon, in Google, or in Azure. And so what does the difference in architecture look like versus when you have it on-prem versus when you have it in the cloud? Is there a different threat model that you have to be aware of? Is there different openings? Kind of wanting to understand that. And then the second part I wanted to understand is what logs are available to me as a defender, because at the end of the day, I would love to lock things down, but I'm working with developers, I'm working with business units. So sometimes I can't lock everything down 100%. So I do need to understand just what's going on so I can look for abuse of things or people misusing things, or, weird things kind of happening in that environment. And, what does it take to turn on that logging? So it turns out that this is definitely not as easy as I would have liked to have been. So we'll talk about some of those pain points about what logs we had to turn on to get the visibility we need, as well as understanding what are we missing in visibility. Again, just so we're aware from a detection standpoint, what do we have at our hands to kind of look at and look through. And the last part here, or next to last part, is understanding how to take the API information and understand that, because while I'm showing AWS here, I'm pretty sure it's going to be the same for Azure and GCP. They're an API first environment. So whether you're using their command line tools, whether you're using PowerShell scripts, Python, even if you're using their web console, all of it translates into the same API calls on the back end to do something. And that's great for us. So we want to understand, okay, in the logs, when we see these things, what APIs are being used, so we maybe have a better idea of what our developers are doing, what our users are doing, and just having a better overall understanding of how our information is going. And so then after that, we're going to go ahead and have a demo and kind of show you what we found here. So this is a document I got from Kubernetes official website here. And so what we're looking at is the overall infrastructure for a Kubernetes environment. And if you notice on the left-hand side, we've got that kind of blue dotted going around the environment. The great thing is all of that stuff inside that blue box is stuff that's hidden from us when you go out to a provider. So essentially the only thing you have is the API that's available to you. So this is great because it does reduce the attack surface, because a lot of the infrastructure is no longer available us to look at, available us to touch, or available us to do to anything that you would normally do. So for me, this is a great thing to know, but great. Now I've just got this one endpoint for cloud for my Kubernetes. What can I do with that in terms of attack, or what else am I going to do? And so one of the things I've learned being in security and IT for a long time is that just because I create some piece of infrastructure doesn't mean I fully understand everything that happened on the back end. How many times, there are backdoors found in applications, user IDs that people didn't realize that were there, maybe configurations people didn't realize. And so I wanted to understand exactly what was going on when I just did the basic, create a Kubernetes cluster, because again, there's a lot of things happening on the back end here. If you're a G.I. Joe fan, you know the GIF there, or the picture over there. knowing is half the battle. So one of the things that was kind of amazing to me is within the AWS infrastructure, there isn't any ability to see exactly what you have in there in a nice, clear, and concise fashion. You kind of have to go to each service and each thing you've deployed to really understand how it's utilized. And so I found this great tool called Cloud Mapper from Duo, who was bought by Cisco. And they gave a great network diagram so I could understand exactly what's going on when I deployed a Kubernetes infrastructure, right? How many hosts are deployed? What are the networks that are deployed? How are things configured? And in looking with this, I also found a great YouTube video here. I definitely, think you should watch it here. The author did a great job not only explaining the tool and kind of showing it. One thing he did that I didn't realize that Cloud Mapper could do is it could do a lot of auditing functions in there. So while I was using it strictly from a network diagram perspective, just to kind of understand everything that I had deployed, there are a lot of useful functions in there that help me understand as well how my AWS environment is being used. Now, granted, it was a personal AWS environment, so there's not a whole bunch of things it could find that were necessarily bad. But in your environment, if it's a production environment, or even a development environment with a few people in there, you're going to definitely find things in there that you might want to clean up, or again, just be aware of what's happening out there. So one thing I didn't realize is that my Kubernetes infrastructure was actually exposed directly to the internet. Now, it is controlled by their IAM, right? Their users and passwords, and with Kubernetes RBAC, but it was still a little bit concerning to me that this piece of backend infrastructure is deployed and has access directly to the internet. Their documentation says best practice would actually be to turn that off and create a bastion host inside that you connect to. And then from there, you could issue your Kubernetes commands that shouldn't have direct access. Now, yes, it is protected with username and password, but like a lot of us, right? Someone creates a really bad username and password, whether it's a service account or just they're playing around and they forget about it. That's going to cause problems because that's just going to make it very easy for people to get in and start controlling that infrastructure and doing things. Logging was not turned on that infrastructure at all. And in fact, I couldn't turn it on when I created the cluster. It's something I had to do after the fact, is go in and turn on logs. Now, once I did that, I got access to a number of logs that were really great because it helped me understand how the infrastructure was working, who was talking to what's just kind of going on behind the scenes. And, turning on the logs was fairly easy, but it turns out trying to get those logs was not nearly as easy. And so if you come from the old school background, kind of like I do of host and network, right, where you want, I want a Windows log. Great. I throw WinLogBeat on something. I say what logs to get, and it just kind of grabs them here. This was very different. And so, we'll kind of go over that. And the other thing that we want to be aware of is that log delays can vary. This is something that is definitely going to impact you in an analytics standpoint, as well as a detection standpoint. Now, it's not saying that this is necessarily bad, but we have to understand that the logs are not going to be streamed in real time necessarily. There can be delays, and we have to understand what does that mean for us. In every one environment, it might be a little bit different. So by default, this is exactly what it looks like in the Kubernetes environment. So after I've created it and I go to the logging page, you can see that all of these great pieces here are disabled by default, which, I wish there was a way to kind of turn it on by default just so it's set. But, once I went in there, it's very easy. I can turn on each piece individually. For the purposes of my demo and just what I was trying to learn and research, I turned everything on just again so I could have a better idea of what I'm seeing and what we're working with here. So there are a few different things that kind of came across here is the names of the logging conventions and as far as where are you getting logs from. So there are two things I had to work with here. One was CloudTrail and one was CloudWatch. So CloudTrail was telling me what's going on in my AWS account. So it was telling me the API calls that were going on, whether it's from a command line tool or the web UI. It gave me information about my S3 bucket, which is where I put my logs to. But when I wanted to look at the EKS cluster itself, this is where I had to turn to CloudWatch. And so CloudWatch is giving me all the detailed information on the inside of that application. And so both of these are going to be very useful, sometimes in combination, and sometimes they can stand on their own. But we really need all of these to kind of work together to understand what we're seeing in our environment. So for CloudTrail, I put everything out to an S3 bucket, which seemed fairly easy to do. I took the AWS course. It told me what S3 is, and I just kind of lived with that, right? It seems fairly simple here. One thing I didn't realize is that there were a couple of different logs to get from CloudTrail here. We have the data events and we have the management events. I have everything turned on again, just so I could get that visibility. And this is something that I encourage all of you to do, is to set up your own AWS instance and play around with this. You can use some of the settings that I have or this demo and understand what you have that's available to you, so that when you go to your environment, your development environment or production environment, you can see the differences, right? Do I get the same level of details? Do I not? Do I need the same level of details or do I not? And this is, of course, going to change based on what your needs are. So one of the great things about the CloudTrail logs is that in Elastic, we have what we call the Elastic Common Schema. So this is a normalized naming convention for all of the events. So whether you're getting Windows logs, Linux logs, logs about your infrastructure, in this case, CloudTrail, whether it's logs from the Kubernetes, all of these are going to be mapped to a very similar naming convention. And the specific field here, the event.action, is very useful because it actually tells me what API is being used. And so now I can start to understand, what does Neil do? Here the API calls that Neil normally does. Here API calls that he normally doesn't do. Or here API calls that I think are very I wouldn't say malicious, but definitely of concern. So anything that starts with delete, right? Whether it's delete a VPC Flow Logs, whether it's delete the VPC itself, all of these things here, we want to be able to be aware of what's going on. So now that we've normalized all of that data, it turns out that we also have some rules around that. So one thing you're going to see from Elastic is, as we've brought the end game people over and they're doing more and more research, we not only have rules for traditional logs like on the network and the endpoint, we also have logs moving into the cloud environment. So right now we have 37 rules that are specific to AWS, and we also have 5 anomaly detection jobs, again, also around those type of activities in AWS. And one thing you're going to find is, just because these rules trigger doesn't mean something's necessarily bad or that you're under attack or that you're compromised, but you might find things like hygiene issues or technical debt that you need to kind of go and fix. And again, just understanding. This is something I see that a lot of security people don't necessarily do or do that often, is clearing up that technical debt so that you don't get all the alerts and you start to understand when is something malicious versus something that's not malicious. And so the first thing I did, right into S3 buckets, I'm like, great, I'm going to use Logstash. It has an S3 input. It'll just read the bucket directly and good to go. Turns out this is not the best way to do it, because when you start to get a lot of objects in there, things slow down. So essentially what happens when we're doing it this, I guess, very rudimentary way of reading the S3 bucket directly is, it's always going to, when it attaches to that S3 bucket, it's essentially going to do like a dir command or an ls. And it's going to say, hey, give me every file that you currently have on there, right? And especially if you start getting into the hundreds of thousands or millions of objects that are there, that's going to take a significantly long amount of time. After it does that, then it has to go through and say, okay, of the things that I know, what are things that are new, kind of find that diff, and then go grab the new things. And so you can see that definitely takes a lot of time. So the other option, which is using FileBeat, but this wasn't nearly as easy for me to get configured. So I had to get the S3 bucket configured. After that, I had to have S3 use the SNS, or simple notification service, to send a message saying, hey, I received a new log. And then that message went to an SQS and that's a simple queuing service. Once that queue had it, then FileBeat would read that queue and say, hey, there's a new file that's available, and it would go read. And so I was unaware of all the complexities needed there just to get a simple log done in a way that's very efficient. But while the scale is significantly better, because every time I go out there, I'm not having to find the new files. I'm actually being told of the files, when they're delivered, what the name is, so we can go specifically grab that. And the problem is, now there's more points of failure because the logs are written to S3. S3 has to send a notification. The notification has to go to a queue, and I have to read a queue, right? And so we've got to understand that there is a delta now between all of these things that are kind of happening here. The other thing we want to make sure is that we configure our S3 buckets properly in terms of data retention, because by default, it's going to store it for as long as you want it to store. And so, of course, your objects are going to grow. So we want to make sure that we retain that to a certain amount, because essentially we're going to be pulling all these back into Elastic. So we don't necessarily need to keep these raw copies out on that S3 bucket. So we want to kind of figure out what that sweet spot is for it so that we can make sure that, we keep them there. And if for some reason, our system's down, we're doing maintenance, or for whatever reason we're not collecting logs, that it has some ability to get backed up, but that we can go grab it. But again, we don't want it living forever out there. And so when I was researching, SNS and SQS and what did I mean, I found this blog about this person who said his SNS has been broken for 24 days, right? And so that means that the business that he built using Amazon services was negatively affected because he was getting alerts 30 minutes late, 40 minutes late. And so what do you do in that situation, right? So AWS is, working with him to kind of correct that issue. But again, we need to be aware that there are going to be delays. So you need to figure out what is the normal amount of delays that happen in your environment? What is a, acceptable amount of delays? Kind of give yourself an SLA to say, hey, I'm going to give myself like a 5-minute window. And so from when an event happens to when I see it, maximum 5 minutes, it should take, and then test that every now and then, right? Go do activities and then look at it in your console. How long did it take to get there, right? Be very scientific about it to where you know exactly who did the work, when they did the work, what work did they do, so you can ensure that, yes, I'm getting exactly the logs I expect to get for the work that was done, and I know this log delay. Once you understand that delay, you can start to monitor for anything that starts to go beyond that delay. Again, just so you're aware of how your environment could be impacted. The next thing I turned on was VPC Flow Logs. I love NetFlow logs in general, and so this gave me another chance to kind of play around with NetFlow style logs. Again, it's not enabled by default, so I had to turn this on, but it allows me to understand who's talking to who, what ports are being used, kind of, all the traffic patterns that are there. And so when you're setting this up, one thing I did is I turned out that I wanted to monitor all the traffic here. Now, you do have an option with your VCP Flow Logs. You can send them to CloudWatch or through an S3 bucket. I personally chose to go through an S3 bucket. I understood kind of how it worked, and there might be a less cost because there is kind of a cost for using CloudWatch. So now that we've kind of gone over, what we've done here, let's go ahead and look at a demo that I've built here and see exactly what we're going to be looking at.
Awesome. So Neil, I'm going to go ahead and elevate you to a co-host, and you should be able to share your screen now.
All right.
Awesome. Looks like we're all set. Okay.
All right. Everyone's set. All right. So here we can see I'm getting all of my CloudTrail logs in here. And again, that field that I told you about, the event.action. So here I can see these are the very specific APIs that are being used in my environment. So I can start to understand, what's being used by what users in here, just get some high level information. But when I want to start looking at the details of what's going on in my environment, I can start to look at the CloudWatch logs. And again, it's going to start telling me, hey, here's what's happening within the EKS environment specifically here. When is someone launching a pod? When is someone doing something? And so I need both of these to really understand what's going on. One thing also I found out with the Kubernetes environment, not that it's neither good nor bad, but anytime that I launch a pod, that pod does have the ability to go to the internet. And so you need to understand your Kubernetes infrastructure, exactly what type of containers are they running? What is the job of those containers? Because usually those things are going to be receiving data from places, maybe processing data. Most likely they are not going to need to reach out to the internet for anything, right? But if they do, you want to be able to understand which pods should get to the internet, which pods shouldn't get to the internet, specifically, write firewall rules around that and be able to monitor for any attempts for people to try and use that in ways that they shouldn't be using it. So one of the great things I look at the CloudWatch logs here. So I was following along with someone else's Kubernetes attack, specifically this blog post here. And I was just following along with the commands of what he did to see, okay, can I reproduce exactly what they did? And then from an attack standpoint, right, when I look at the logs, when he does the commands, or when this person does the commands, what do they look like in the logs? So over here, I dropped, my own pod here. And so one of the things I got to see is what type of image is being used for this Docker container. So this is something that you can start to look for in your environment to say, hey, these are the types of images that we will standard build in our environment, and then start to look for images that are not normally used in your environment. If you haven't restricted it, be able to understand that. Look at the naming convention of your pods, because it's probably going to be something that you have very similar. And if an attacker tries to do something, they may deploy something that's kind of out of the norm there. So these are things, we can look at to understand in here. So we get a lot great detail about what's going on in an environment from both the API perspective as well as inside the Kubernetes perspective. From the VPC Flow Logs, we get a lot of information as far as who's talking to what, what's going on in the environment. One of the things that I did not realize is there's certain parts of the VPC environment that are not logged in. It was kind of a surprise to me, but when I started to look through the documentation, sure enough, it says it right here, right? So this is the thing that we're looking for. This is the thing that's of concern to us, these instance metadata, but traffic to this IP address is not logged. So we do need to look for other ways to kind of get that information. So I can see new pods being deployed. I can see kind of what's going on with that pod. But again, when that pod starts to talk to the instance metadata, there's no visibility that I have, unfortunately, in that. So we just need to be aware of that limitation. And then when we look at the detection, so we're looking at 7.9. So this is just me doing my general work in my lab, playing around with it, trying different things. We can see the various things that are turned on here. So here's, me logging in as root a bunch of different times because I didn't create a different identity, different log groups being created, flow logs being turned off. And again, these are just things that, we should be aware of, because we want to know exactly what's going on in our environment at any given time, from a perspective of that infrastructure. When we look at all of the rules here, so I can go and look at the tag of all the rules. So the one specifically to AWS, I've got 37 rules right now that align to this, so we can see exactly what they are. You can go and look at any of the rules here. And if you have questions exactly what it's looking at, you can always just go into the details here, and it'll give information about what that rule is, any references about that specific rule, how it aligns to the MITRE ATT&CK framework, and specifically the query and index pattern that it's looking at for that information, right? So it makes it definitely easier for people to kind of understand what they're seeing there. And then on top of that, if I can move this out of the way, we can see that machine learning jobs specifically related to this. So if I look at CloudTrail logs, I've got 5 specific CloudTrail logs that are all related to finding this. So we're giving a lot of good detections on this to help people understand. One thing you're going to hear me say, if you hear me talk at different customer sites or other presentations, is that Elastic is really good at letting you know something is different, right? We're not saying that something is necessarily malicious or something bad happened. We try and let you know that something is different that happened and you want to be aware of it, right? Because a lot of times it does take a person to look into it to understand exactly what's going on to make the determination is something is good or something is bad. So all that is, what we're talking about here when we look at this Kubernetes infrastructure. And the other thing that I really don't have on the presentation here is understanding, right, how do people get access to this? So your developers are out there, they're going to have the command line tools to be able to do this. But when they set up these command line tools, they're going to set it up essentially kind of like with SSH keys, to where they don't have to enter in credentials every time they do something. They can just type a command and it'll go ahead and launch a pod. They can look at information. They could do whatever they want. And so the problem with this is whoever is doing this activity in your environment, you need to monitor their activity. You need to monitor, okay, the host that they're doing this from. Is this a host that we have additional protections on, additional detections on? What is the level of security that we have and monitoring we have around that? Because if someone compromises that specific host, they now have full access to that Kubernetes infrastructure. And if you read some of the blog posts that they have access to the Kubernetes infrastructure, they might have full access to the entire AWS infrastructure, right? So we really want to be able to monitor those hosts that are doing it. And this might be something that you end up working with your team to detect, to say, hey, we're going to have a certain kind kind of a bastion host out there. This is the only host that you can do admin activity from, and that, you have to come into there, have dual, MFA to get onto that box. And then from that box, you can do whatever infrastructure changes you want to do, but that you can't do it directly from your laptop, from your desktop, or your home, or anywhere else. But, again, by controlling where things come from, you'll have a better understanding, what's going on in your environment and how things are working overall. Let me give control back over. So that's all I had today. So I'm open to take up any questions here during the rest of this talk, or, on the Slack channel there.
Neil, thank you so much. I have to say that was an amazing presentation. Like, you could feel the energy, not just from you, but also from your colleagues on Slack. Like, I love how you guys were, sharing some job postings that you have open right now, and asking for resumes and people to apply to that. So that's great, and especially these times where people is going through rough times and difficulties. It helps. It helps everything you guys are doing with the community, for sure.
Elastic is definitely a different place. I don't want to sit here and preach about Elastic necessarily, but I've been here for 2 years. It's been an amazing ride. The way that they treat people, the way that they do things. And Shai doesn't talk about everything that he does, but he does a lot for the employees to ensure that they have a great working environment, right? So tomorrow, in fact, we have a day off because a lot of people talk about their shut it down days. Elastic was doing that before everyone else talked about it. So we have 2 days a month that the entire company shuts down. So that way I don't email you and you feel like you have to answer an email. If everyone's off of work, right, you have the ability to relax, recharge, and try and get your mind together, because you're right. These are definitely different times or difficult times. And I love what Shai and the team at Elastic are doing to really help sure that all of us are able to work, effectively. And they worry about our families as well.
We can see that and really appreciate it. So thank you guys. I know you have a lot of questions there. You can go there and spend some time talking to the audience. But I want to ask you a couple of things. I've been asking the previous speakers about how they see the world of security operations evolving, but which is, I think it's a concern for maybe many of the security people that might be trying to learn more about DevSecOps. So that's maybe another question for you. Is like, you talked a little bit about that. If I want to learn more about Kubernetes, right, the world of Kubernetes and how to manage these containers at scale, what do you suggest we do, right? What can we do there?
That is the age-old question, right? So the problem is with that, it's a very hard thing to learn. There's not here's a getting started guide. But there are a few people, Ian Coldwater, Brad Giesman, Duffy Cooley, that I followed on Twitter, and they did a number of talks at like RSA, Black Hat, even on their Twitter feeds, and they're a wealth of information. But a lot of it is playing around with it, right? I honestly, I was scared to play with it because of how overwhelming it felt. But I'm like, hey, I just got to do it. So I created my own AWS account, read blogs, just tried things. The best thing for me though was turning on the logs as soon as possible, getting those logs back into the Elastic Stack, just so I could understand when I do this one activity, what does that exactly mean, right? Kind of like RDP. I used to think I knew how RDP worked till I had to actually look for it in event logs. And I realized there's not one specific event log that's RDP. It depends. Are they, restarting a session that they already had, or is it a brand new RDP session? There's so many different nuances that you have to be aware of.
Excellent. Thank you. Yeah, and I liked how you used Cloud Mapper as well as a tool to visualize what you have audited.
And very to me, that's important. When I was a consultant, how many times I'd go to a client and say, hey, do you have a network map? Right, to understand, because if I'm a socket, I have to know what I'm defending. If I don't know what I'm defending, I'm not sure how I'm supposed to defend it. Right. And I go to customers like, well, we don't know how we get to the internet. I'm like, so if we don't know how we get to the internet, then you don't know how attackers get in and leave. That's kind of a problem for me. And so this was very similar, right? I want to understand the cloud is nice when we talk about it generically, but you need to understand from a realistic standpoint, what was deployed when I did this one command, right? I just said, create a Kubernetes cluster. I didn't know it created a VPC for me, all these subnets. And oh, by the way, put my host directly on the internet. Right. Yes, at least it had authentication, which is a good thing. I never would have expected to be open to the internet. Right.
There's no substitution to what you said, right? Like getting your hands dirty, rolling up your sleeves, and actually doing it so you can see what's going on. Yeah.
Exactly. And I think it makes us better practitioners when we understand exactly what's going on. We can talk more intelligently with the end users and developers about what we see and what they're doing. When we can say, hey, I see you doing this, or, can you change? And a lot of times in my experience when I ran a SOC is sometimes I have to change the way people work so that I have a better understanding of exactly what's going on. When I started IT, people did develop their admin work from their laptop, right? So they were domain admins logging into their laptop as a domain admin, doing that work. It's like, no. Let's create two accounts, your user account and your domain admin account. Then after a while, we're like, hey, let's get beyond that. Let's make sure that the domain admin account can only log in from a specific jump box, we call it, right? And then we put heavy auditing on that box and did a lot more there. But that helped us understand exactly how things should be. So when an attacker comes in, hopefully they stand out. They shouldn't be doing exactly what our admins are.
It's a cultural change as well, right? It's a lot of that.
Yeah, a lot of change. And so these are things, I think we need to take those same principles that we did on-prem and do that in the cloud as well, right? That part doesn't change what we're doing.
Totally agree. Thank you, Neil. There's one more question, and there's several more, but I'm going to pick one from the audience. This is Tim saying everything AWS Kubernetes is specific. Is this relevant, applicable for in-house cloud Kubernetes as well? Same risk profile? Is it the same as public facing?
So when you're doing it yourself, there's a different risk because you have all those services that were kind of in that blue box in that Kubernetes diagram. Those are all now exposed, right? So people can attack like your etcd server. There are other attacks they can do, which other people have talked about. The other thing is, when it's on-prem, you also have the ability to say, hey, I can essentially do what they do in Amazon or whatever. I can firewall those off. So I can have those services, but I can put it in such a way, right? So they are limited who can access them directly. If everything's just on a subnet and everyone has access to it, then yes, you're going to have a richer profile for people to be able to attack. And that also determines, what kind of logging do you have available. But whether you're an AWS, GCP, or Azure, the cloud provider Kubernetes services very much look the same. You have that single API server that you interact with. Everything else is hidden behind the scenes, so you don't have to worry about that as much.
Excellent. Well, thank you, Neil, again for your participation.